It's my great pleasure to be invited to give this talk. Thanks for Joseph and Michael and Ingo for inviting me. So I know the audience has two parts. One is from kind of acoustic side, who know a lot about acoustics, including our leading expert like Brigitte in soundscape. And we also have audience from architecture side, who might not know much about acoustics. So I'll try to get a kind of balance. So the topic today is about designing soundscape in urban open public spaces. The keyword is how to design soundscape. And it's mainly about a framework and potentials, what factors we can design and how much potential we have. That's the kind of key message I'd like to explore with the audience today. So my talk will include this part. One is give an introduction about from noise reduction to soundscape creation, background, what is soundscape, why we do it. And then I'll focus on a framework of designing soundscape, what kind of factor we can design, what's the potential of it. And then I'll talk about some design tools and also soundscape examples. And very briefly about some more information from the cost action on soundscape and the current project. So firstly, what is soundscape, why we do it? And firstly, effect of noise, what's noise? I know that's very kind of common knowledge in acoustic field, but because there are some architectural colleagues, I'll just repeat some information here. So we know some years ago, now it's still similar case. We have many EU citizens suffer from acceptable environmental noise level according to WHO. And according to EU official data, the social cost of transport noise itself is about 0.22 to 2% of GDP, which is a big number if you translate this to euro. And of course, we know noise effect, including hearing impairment, speech interference, sleep disturbance, but also performance reduction and social behavior change. And also noise will have effect on loss of property value. Every dB increase will decrease property value by a certain percentage. And we know EU directive require every city do a noise map like that. So that's one line of action. Noise is important if we need to reduce noise, no doubt. But on the other side, we did a survey in an urban square in UK, Sheffield. And we asked people two questions. One is, how loud do you think he is? And then in the same time, we measure sound level. And that's the sound level, that's people's answer to this question. You can see with increase of sound level, people do feel it's louder. But we also ask people another question, how acoustically comfortable here you feel? And that's the answer. You can see below certain level, about 65 to 70 dB, the relation between physical property, which is sound level, and people's subjective evaluation is very weak. And if you reduce sound level, people wouldn't feel more comfortable. Although above that, if you increase sound level, people do feel less comfortable. So this gives us great indication. Below a certain level, we need to design what kind of sound according to who are listening, who are you listening with, or this kind of information, non-acoustical factors. Above a certain level, you need to reduce sound level first. So this kind of indicates we need to do something beyond noise control. And a recent example is we found noise complaint increased a lot in lockdown period, which means the sound level actually, as we know, reduced a lot, 10-15 dB. But in the same time, people start to complain more when city become quieter. That's because when city become quieter, certain sound become more annoying. So we need to kind of balance different sound sources rather than just reduce noise. Like lockdown is golden opportunity to prove that. So soundscape is defined by ISO as acoustic environment as a perceived or experienced, understood by a person or people in context. So the keywords here is about perceived. So we need to focus on perceived sound environment rather than just the decibel level, which is the focus of noise control. And suddenly, the soundscape field become much more related to different fields rather than just the noise control engineering, physics. Is related to science, engineering, social science, humanity, and arts. So another keyword of soundscape is regard sound or sound environment as resources you can use to promote health, attract investment, or keep cultural uniqueness and enhance quality of life. Rather than reduce negative effect, you can increase positive effect. So soundscape has these two keywords. One is perceived, that's the focus, and also the promoting positive effect rather than just reducing negative effect. Soundscape research or practice was really pushed by the EU directive of identify quiet areas to protect, because before this directive is stay on the research side, but because the EU directive require a lot of actual action, practical demanding, actually push the research a lot. In recent years, there are so many activities and the number of papers published in soundscape is increasing very sharply. So that's a kind of background. I hope that's not too boring for our soundscape expert who knows this very well. And now I'll focus on a framework of designing soundscape. So before I talk about what factors we can design to achieve what kind of potential, I'd like to say something about design process of soundscape. Because designing soundscape, the process is very different from noise control engineering. Noise control, you have clear targets. Now we have 55 dB noise level, we want to reduce to 50. Then we have clear treatment like noise barrier or sound absorber, whatever, you achieve it, that's it. So you don't need to talk to anyone. If you are expert, you just achieve it. But the soundscape design is different because it's about perceived. It's about experience. So it's somewhere between architectural design and also kind of engineering design. So the design process is very different or complicated. We have different stages: startup, preparation, and understanding and evaluation, and further development. And we need to consider what we want to achieve, we need to involve, and what kind of method is best method to engage people, and what outcome we should get. So this is a systematic study about how this was derived and what need to be included through some example case studies. But the design process is not my focus today. It's mainly about what we can design. It's very important to put that what we can design into that design process into the whole picture. Otherwise, it becomes another side of engineering design. So come to what factor we can design. As a designers, either acoustic designers or architectural designers, what we can control, what we can change include sound sources. For each sound source, we can change or control sound level, spectrum, how it changes with time, how long it lasts, whether it's impulsive or steady state, and location, and source movement, and some social psychological characteristics, like a meaning or whether it's sound mark or not. From physical to more social side for each source, that's something we can design. For example, if you design Big Bang in London, it's different from design Big Bang in Aachen. Another side is we can design space. For example, whether space like urban square is reverberant or not, and a reflection pattern, whether it's focus point, and whether it's a quiet place in a noisy area or noisy place in a quiet area. What kind of sound sources around that space you want to design? So that's also another side of designing space. And because soundscape is about users, it's not about designers. So we also need to design for users what kind of people are using it, because they're demanding different. I'll give you more information. And what is acoustic condition of users at home and at work. And another side is about other environments. We design sound, but we can't just focus on sound itself or only consider sound. We need to consider interactions between sound, temperature, sound, and the lighting, visual, audio interaction. Because if a place is extremely noisy, who cares about the other aspect, or vice versa? So that's kind of something as a designers we can control or in our hand. Now, the question is how we can design it and what kind of potential we have. I know there are so many potential, so many aspects to talk about, but I'll just give you some ideas to kind of start with so people can think about it. And before I talk about it, so I suppose everyone can talk about their thoughts, how we can design these factors. But to be more convincing, there should be some evidence. Otherwise, your guess is the same as my guess or better than my guess. So to make effort to make the what I present more convincing, actually, this is all based on long-term, large-scale survey and case studies we did across EU and also UK. Now we can say they're different, and also China and other countries. So we did about over 10,000, now maybe 14,000 surveys at the different stages, and also measured a lot of sound field and also other problems like humidity and temperature of different squares. So we can relate what kind of physical property they are and how people perceive sound environment. So this can guide us about the design potentials. So based on that, I'll just give you my thought about how to design sound, how to design space, and design for people and design other environments. So for sound, there are different definitions about how to classify different sound. From a designer's viewpoint, I think we can define sound as active sound and passive sound. Active sound is related to sound from activities. For example, group dancing, which is a very common activity in China, in Chinese squares. And the passive sound is like a fountain. So the difference between active sound and passive sound is active sound will disappear when there's nobody there, because soundscape is about the perceived. And passive sound is about sound always there, like a running fountain. Of course, you can switch it off, but yeah, it's kind of part of square furniture. So from these two kind of sound. We can design the spectrum, how it changes with time, and also different zones. So music is typical active sound. Our survey shows for live music, people are not only considered or interested in music itself, but also attracted by the activity of the players. So in that case, the type of music is not that important for live music. So it's live music. And but for music played using loudspeakers, the type of music is more important. People like certain kind of music, not like other kind of music. And for example, also people don't like loud music played from loudspeakers, generally speaking, compared to live music, and also from passing cars. So same sound source, same music, if it's from different source, it's very differently perceived. And we can use music to mask unwanted, for example, background noise, if we consider spectrum and also time variation. And water is a typical passive sound. It's just like foliage in landscape design. Water in soundscape design is kind of primary soundscape quality. And normally, the spectrum, as you know, water is at higher frequencies, and but some do have notable low frequency component. I'll give you some more example next slide. And in terms of dynamics, the flow rate of water should not be consistent. We found people like sound of water with varied flow rate rather than consistent. It's a bit boring, I suppose. And again, we can use water to mask unwanted sound by considering spectrum for energetic masking. So that's an example of what kind of potential water could have. We measured a range of water features in Chatworth Garden, which is a famous garden in the UK. Several very famous films were made in this big garden and house. And in the garden, there are a range of fountain water features. This is, I think, tallest natural powered water feature in Europe. So basically, because there's a hill on the other side, so naturally the water come down and be raised up. Big lump of water dropped in a quite deep pond. This generates quite low frequency sound, like this one. And also there are small streams which has very strong high frequency component. So same water from same source, you can design it like this, very high frequency, or design it like this, very low frequency. And this one can be used for example, if you want to use masking effect. Masking, for example, children's shouting, this one can be used for masking train noise, for example. And also in this garden, there's an interesting water feature. It's because of hill, there are many steps, water running down. And according to landscape book, this water feature will generate music if you walk down. So we measured it, the spectrum at the different steps. It's not quite musical, but at least it's very variable and interesting. So water, that's a potential, not only generate a different spectrum, but also can be kind of meaningful and make it interesting, so people perceive it differently. So that's about sound. I hope this gives you some kind of idea about sound design, although there are so many other kind of sound we could design, so many other potentials. About space. So to see how much potential we have when we design space, for example, if we have a more enclosed square compared to open square, what's the difference? if a high-rise building around the square, what's the difference? We need to simulate sound propagation in that urban environment, street or square. So we developed it in within a quite long time period. Developed it different simulation methods like image source method and radiosity model, and combined ray tracing radiosity model to simulate sound propagation in spaces like urban squares. I wouldn't go to detail on this model, but the focus today is what's its potential. So using this model, we calculated that's a typical square. That's sound source to receiver distance along diagonal of a square. What I want to show here is if you, that's source receiver distance, that's sound level reduction when you move away from source. So same source receiver, if it's within a square of 25 to 25 meters, and then sound attenuation is like this when you move away from source. Without moving source and receiver, only change the square into 50 by 50, and then you can see that. Change to 100 by 100, you can see that. So that means with a fixed source receiver distance, if you are 20 meters away, when you increase square size, the sound level will be reduced by about 5-10 dB, and further reduction will be given if you reduce, increase the square size further. And if we fix the square into 50 by 50 and just increase building height around it from 6 meters to 20 meters to 50 meters, then that's what you get the difference. For example, 40 meters away or 20 meters away, which is quite significant, about 10 dB. You will feel, acoustician will know that the doubly quieter or doubly louder, depending on whether you increase or decrease the building height. If you keep the area of square same, consistent, just to change the aspect ratio from 50 to 50, change to 100 by 25. And the difference is much smaller, although if you are further, then there'll be some differences. And if you don't change anything on the dimension, physical property of it, just change the boundary condition by changing, for example, brick wall, concrete wall into brick wall full of vegetation, which is more absorbent acoustically. And this is brick wall, typically absorption coefficient of 0.1. And if you increase the absorption coefficient, for example, increase the vegetation on it and increase to 0.9, and then you have very big reduction. So without changing the, because people say, I can't change the square size or building height, it's fixed for 100 years, 300 years, how can I do it? Then you can do something on the facade treatment. It's also very effective. If it's further away, then you can have about 15 dB difference. So that means if you change the boundary condition at the same distance away from a fountain, you can feel very differently in terms of sound level. And in previous slides, I always show two lines. One is, maybe you notice, one is diffuse boundary, another one is geometrical reflecting boundary or specular reflecting. Architecturally, one is smooth facade, like glass curtain wall. Another one is diffuse facade, like classical European facade full of decorations. So if you don't change anything, square physical property and absorption, just change the facade treatment from diffuse to specular or specular to diffuse. There are also some differences. That's the difference between the two extremes. For sound pressure level, it wouldn't change too much. But if you look at sound reverberation time and early decay time, and that's index used for room acoustic load, but they're also very relevant to urban spaces for people's perception. So this can give you very big differences, even the material is the same. That means if you generate impulse, for example, along with time, if you have diffuse boundaries with a lot of decorations, in other words, the sound will die away very quickly. And if you have smooth facade like a glass curtain wall, then the sound will die away with time slowly, which means longer reverberation time. So if we can't change the source and can't change the square dimension and the facade, we can also do some kind of source arrangement or management by arranging different sources into different zones. Then we can also change the sound field. For example, that's area in the Peace Garden I mentioned before in Sheffield. By arranging sound source in different areas, you can also create a different sound field. This is sound map. So this is a fountain, and move away from fountain, you have a nice sound level, and that's a road. That's the highest level for road noise, but then move away, it become less. So rather than noise map, I showed you in first slides. Now we move to sound map, which consider positive sound and negative sound together in one map. So you can see where is the overlapping, how we can design it together. So that's one step further from noise reduction. We move from noise map to sound map. So people, we can't design people like we design space, design sound source or square, but we should design for people because people demanding are different and there are different users. So before that, we need to think about what are the differences between different people in terms of sound evaluation. Again, this is based on large-scale questionnaire survey, and we found in terms of sound level evaluation, how loud the place is. Occupation and education have more influence than other factors, including age, gender, and whether they're local or not local. And for some behavior factors, such as wearing earphones, reading, writing, effect is also is less significant. The watching behavior is highly related to sound level evaluation. Whether they're watching somewhere nice or not is very important for their evaluation of sound, which indicate visual-audio interaction. And for acoustic comfort evaluation, the effect of watching behavior is even more significant. So basically, people prefer natural and cultural related sound. Majority of people prefer that. And also long-term environment experience are important for people's evaluation. Whether they come from noisy home environment or work environment will affect their perception on sound in actual urban squares. And also demographical factors influence people's sound preference a lot. That's evaluation of bird sound. We ask people, do you feel bird sound is favorable or annoying? And this is with increase of age. You can see more people feel sound is more favorable from birds. And that's about car music. You can see with increased age, more people feel annoying. So that means between older people and younger people, there are a lot of differences in terms of sound preference. So we need to design different zones if they're all using it, or if we're designing a square for users mainly from older people, we need to maybe introduce more natural sound. And also there are a lot of cultural differences. This is comparison of different countries in terms of sound preference, again, favorable, neutral, and annoying for different sound sources. And you can see for water sound, German and the English people are similar. They like water sound, favorable. But that's not true in Italy. In Italy, or some city in Italy, majority people think it's neutral, not that high for favorable. And differently, for surrounding speeches, English people and German people are similar. They kind of think of this neutral, not like it so much. But in Italy, about half people think it's favorable, like surrounding speeches, half people think it's neutral. So you can see within Europe, there are already some differences, cultural differences. And with different home environment, castle has quite its home environment. Animals in Greece has noticed. And in that case, with similar LEQ in urban squares, the evaluation score of castle is much higher than in animals. So they perceive urban square environment very differently. Even further, that's another comparison in cultural difference between Sheffield, Taipei, and Beijing. We ask people, would you like a sound from outside in terms of bird sound? 70 people in Sheffield like it, and that ratio is only 32 in Taipei and 25 in Beijing. You can see a very big difference. And we also ask people, do you like music from outside? Only 4% of people in Sheffield like it, but 26% in Taipei and 43% in Beijing people like it. So you can see this big cultural difference when distance is further away, bigger than that. So we need to design for people, think about who are using the place. And the fourth parameter is about the environment. So if a place is very hot, 50 degrees, I don't know whether people will care about how noisy a place is, what's the soundscape, vice versa. So a lot of research has been done. This is a study. We ask people to evaluate different aspects, temperature, lighting, wind, and we did a principal factor analysis and found view and sound level always within one kind of principal component. That means audio-video interaction is quite important. And another study shows that we ask people, when you choose living environment, what do you consider? The many factors like transport, view, and quietness. And again, quiet and view are always related. That's the same in Beijing, Taipei, and Sheffield. So people who like quiet environment, they also like better views. So this shows kind of human beings' basic kind of demanding in terms of sound and visual aspect. And that study we did with medical doctors to prove or to explore what's the physiological basis of it, because that's or psychological evaluation. So we use artificial sound like white noise, sound like seaside or sound like motorway, and give people different video, water and motorway video, and see whether the visual information will affect people's auditory perception or physical reaction, and by people scanning people's brain, and the effect was showing. That means audio-video interaction not only psychologically proved, but also physiologically proved. And in addition to audio-video interaction, there also interaction between sound and smell, for example. We did a simple experiment. Along a busy road, the traffic is always consistent. And we ask people's evaluation of noise, annoyance. when there is flower smell from trees and without in different seasons. And this is difference between without and with fragrance. And you can see evaluation of overall comfort and traffic noise and auditory satisfaction are all different without smells. There's also interaction between sound and thermal interaction. So basically, we surveyed people's sound evaluation in different seasons and see whether they are different. That's for evaluating different sound preference. And theoretically, in different seasons, if there's no difference, this line should be same. But if there are variations, that means different seasons have different evaluations. You can see for different seasons, they're not a straight line. There are always some variations. That means the temperature or thermal comfort affect people's evaluation of sound preferences a lot. That's one study, but we also had a third study that shows in different levels. So I hope through these four kind of as catalogs, I show you some kind of potentials of designing sound, space, and design for people, and also design in terms of environmental conditions. So following that, I think designers will need some design tools to aid them to design. I just show you some work we did, and I'm sure other colleagues are developing other tools. One is artificial neural network model. So because we had such large scale survey, so actually we as a kind of model is quite experienced to know in what kind of situation, for example, big square, small square, what type of square, and what sound level will generate what kind of soundscape results in terms of subjective evaluation. So because of this basis, we can develop this artificial neural network model to predict something new, which is within same range as what we surveyed, but it's new square. So what it can do is, if you, based on this large database with AI model, we can predict a new square in a map. For example, if you have new design with different locations, you know what sound level this place is, what's the view condition, and what kind of user profile this is. It can predict, tell you if group of age 13 to 18 use this square, sit here, and they will feel this place is quiet. And if it's group with older age and sit in the same place, they will feel this is also quiet, but towards neutral. And if it's different education level, again, sit here with secondary education level group, they will feel this is quiet, but higher education level group will feel this is noisier. So we can tell how people will perceive a place differently. Therefore, we know whether the design is successful or not, according to who are you designing for. So another tool is organization. I know Aachen Group is a world leading group in this. So we know to aid room acoustic design is quite mature and so many work has been done. But to aid open square or open public space design, there are some challenges. One is so many sources, and also source and receiver all moving, and also different from room acoustics. The calculation speed must be fast because people can wait for 2 months to get good results for a concert hall design, but they can't wait for even 2 hours or 2 minutes for an urban square design because this is only part of the whole design for architects. So we really need to have nearly real-time results. That's all challenges, but the good news is this is not concert hall. We don't need to be so accurate. We just need a general kind of rough feeling of this to aid the designers to see whether the design is good. So the calculation accuracy is less critical. So the challenge here is, so where's the boundary? So we did a lot of work to see what's needed for this kind of design and what's acceptable. For example, we found if you simulate fountain, you don't need to simulate any reflection. Direct sound is enough. This can greatly increase the calculation speed. But if you simulate speech, then you need about 5 reflections to be kind of acceptable in that kind of situation. So this can also give you some kind of indication about how to balance speed and accuracy. So that's, I think, the key part of organization rather than the technique itself. Another side is design guidance, because sometimes designers will think, okay, it's fine to have AI model, but we don't know how to use it. And although it's easier to use, but it's still for us, it's too much. And organization is okay, but still maybe we can't use it all the time. So maybe some simple design guidance would be useful, just to say what you need to do. Step 1, step 2, step 3, and very simple guidance. So that's something we developed quite a long time ago, but I hope that kind of work can also be done by other people in different places. So then I'll give you some soundscape examples, but because I know there are some architects, they won't know some real examples rather than just a kind of theoretical explanation. So Sheffield Waterscape or soundscape is quite an interesting example in terms of soundscape design. Basically, Sheffield was a steel city. It used to be steel capital of Europe. And so for steel city, water and mining is key. So water used to be quite big theme in city design, but then with the declining of steel industry, water was forgotten. And with city center regeneration, water was rediscovered or installed. So around the city center, there's a gold route with a lot of water features. So we studied this water feature and see what it can do. It was also showed in BBC once about different water features. This is, again, the Peace Garden, Central Square. You can see 1 meter from source, 4 meter, 9 meter, 19 meter. The spectrum will be very different, sound level and dynamic pattern are also varied. So this shows greater potential for designing soundscape even within 20 meters. And that's another example of that gold route. It's quite different. That's the spectrum. You can see it's very, very low. Actually, there's almost no sound. But because the water is running, so people's attention is attracted by this water feature. So different from previously I said, energetic masking, you use sound to mask another sound. This is kind of attention masking. You don't need to have loud sound, but because you attract people's attention, even by very low sound level. So people pay less attention to other unwanted sound, they pay more attention to this sound. So that's another very useful treatment for soundscape design. This is interesting example of soundscape design, the railway station square. So that's railway station, and that's in front of it is a quite busy road. And previously, it's quite unwanted place. It's noisy, and air pollution is also quite strong. People just go through it. And then there was a steel barrier, stainless steel barrier built. Sheffield is the place which invented stainless steel. So it's got some cultural meaning. And on this, there's water film on it, running water film. So on one side, it reduces noise. On the other side, generates positive sound. So this is quite a classical example of soundscape design. At the same time, there are many other water features to make it really rich and interesting. And that's in front and behind the steel barrier. You can see the sound level is very different. And yeah, I can, because I don't want to create some technical problems, I wouldn't play any sound. But I'm sure you can imagine the sound level in the roadside, also behind water film noise barrier. And at the different places in the square, there are big diversity of water sound. So if you walk at a different point, you feel it's like you are in a concert hall from water feature. So soundscape is not about designing urban public spaces, but it has a wide range of replication. So this is a book based on cost network, and Brigitte and myself edited. The last chapter of this book, led by Lisa and other colleagues, collected some examples. And this ranged from some are in the book, some examples are not in the book, but I just show you what kind of range. Soundscape can also be used for designing rural soundscape, and also large-scale soundscape planning of a city, and the soundscape conservation of, for example, that's an example in Lhasa, Tibet, and also transport management. In London, in one place, people want improve soundscape, therefore get rid of all cars, just leave buses. But the problem is, if you only leave bus, maybe people are more annoying, because rather than kind of steady state noise, you have very impulsive noise from each bus. So you spend money, reduce noise level, but the people are not necessarily happier. So management is quite important. And that's example for managing delivery sound for small shops. And with the same delivery sound, because the context is different in quiet area, green area, noise area, people are perceiving it differently. Therefore, you have different complaint rate. So this is about how to predict that and to manage soundscape. And this is Brighton famous example of West Street. I think many people heard of it, using music to change people's behavior. And at the end of this road, the tunnel, we also try to use music to guide people to use tunnel rather than go to roadside to be hit by the car. So you can see there's a range of things we can do with soundscape perception concept design. So finally, if you want have more information on soundscape, there are a lot of papers and work done by colleagues across Europe and beyond. And one place to find this is the Cost Action website. We have cost book, e-book, several hundred pages with a collection of papers from many colleagues in different universities and organizations. And finally, our current work is EU ERC grant developing soundscape indices. Firstly, carried out a big survey to find out what's the relation between physiological, psychological, physical, and contextual parameters. And based on that, we developed some intermediate parameters, like how these factors affect, for example, eventiveness, vibrancy, and hopefully at the end we can develop some kind of single index, ranking kind of index to evaluate soundscape, rather than using sound label to say whether this place is good or not. Traditionally, it's like that. We can develop some indices to evaluate soundscape, integrate people's perception into it, rather than just the physical sound label. So that's the target of this project, ongoing project. Maybe a bit more than what I should speak, so I'll be quick. And to conclude, I hope I demonstrate the tendency from noise control to soundscape creation, and also through the framework and some examples demonstrate the potential of soundscape design in terms of sound, space, people, and environment, and also in terms of design tools and example. And I hope we can work together to work towards the practice and policy for soundscape design and improvement. If you want more information, some papers, everything I said have some evidence. You can find this evidence from the papers. Google Scholar maybe is a good source. And finally, I'd like to thank all my team members who made a contribution to this presentation, the work, including presentation, and also funding bodies for funding the research work. And finally, thank you very much for your attention. I hope that's useful for colleagues both in acoustic and architectural field. Thank you very much.